All right, this is the third lesson, sector area and arc length. So a sector of a circle is a region bounded by two radii and their intercepted arc. So you'll see in the picture to the right what a sector would look like. Now to find the area of that sector, which is what we're going to focus on, is using a formula below where you want to find the area of the circle first. And once you know the area of the circle, you want to then multiply it by the degree of the central angle by 360. And that will give us the area of that sector. All right, problem 1. Find the area of each sector in terms of pi and the decimals rounded to the nearest hundredth. All right, so we are trying to find this sector, its area. We're going to use our formula we saw on the last slide. And the m is representing the degrees for that sector. So 210 will be our m over 360 times pi times our radius squared. Our radius in this problem is 3. So we will then have 210 over 360 times 9 pi. We get 9 from going 3 squared. That's 3 times 3. Now we have this big old fraction that we want to reduce. So we're going to reduce the fraction by 30. So we're going to divide the numerator and denominator by 30. When we do that, we're going to end up with 7 over 12 times 9 pi. That's really 9 pi over 1. Now we're going to do, we're going to reduce again, but we're going to cross reduce. So we can reduce the 9 by 3 and the 12 by 3 as well, which makes 4. And so now we have 7 times 3 pi, which is 21 pi, over 4 times 1, which is 4. We can also write this as a decimal of 16.49 inches squared. We're using inches squared because this is area. Our next one wants us to find the sector of AOB, but this time they provide the diameter. And we need to remember that the radius is half of our diameter. So this is going to be 0.8. And then we just go ahead and fill in the formula. You can see we have a semicircle. That means our angle measure is 180 degrees. So 180 over 360 times pi 0.8 squared. So 0.8 squared would be 0.64. So we have 180 over 360 times 0.64 pi. Reduce the 180 over 360 down to 1/2 times 0.64 pi. So half of 0.64 should be 0.32. And putting it in terms of a decimal, we can go ahead and times 0.32 by 3.14, giving us 1.00 centimeters squared. All right, problem 3. Find the area of the described and round to the nearest hundredth. A beam from a lighthouse is visible from a distance of 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? So if we look down from the sky down to the lighthouse, seeing the very top of the lighthouse, looking down from the sky, we have a beam of light that goes out 3 miles. Now it does a sweeping arc at 150 degrees. Now remember that in reality a lighthouse can spin a full 360, but we only care about the 150 section. So we go ahead and we just plug it in, 150 over 360 times pi 3 squared, so we get 9 pi we want to go ahead and reduce 150 and 360. So 150. So 150 divided by 30 will be 5, and 360 divided by 30 is 12. We can go ahead and multiply and simplify. So using some cross simplifying, we can reduce this by 3. So we end up with 15 pi when we go 5 times 3 pi over 4. Putting that as a decimal to the nearest hundredth. So 15 pi divided by 4 is about 11.78 miles squared. All right, so this is a problem that is from your IXL assignment for this lesson. And it's one of the harder problems, so I want to kind of go over it so you understand how to tackle this. It says the radius of the circle is 8 meters. What is the angle measure of the arc bounding a sector with the area of 8 pi meters squared? So it's essentially asking, what is this arc measure in degrees? So to do that, we're still going to use our formula. So the area m over 360 times pi r squared. Now they gave us the area, 8 pi. We're trying to find m. We don't know that angle measure. And our pi is just pi, but our radius is 8, it tells us. So we go ahead and we solve this equation. Start off by squaring your 8. So you have 64 pi. Then I want to get m by itself. I'm going to go ahead and divide both sides by 64 pi. Then I'm going to go ahead and reduce. So the pi's are going to divide away. 8 over 64 reduces to 1 over 8 equals m over 360. Now you can use cross multiplying to solve for m. So 8 times m is 8m. 1 times 360 is 360. Divide both sides by 8, and you learn that m will be 45 degrees. So that means this arc measure is 45 degrees, the central angle measure is 45 degrees. You now know that angle measure. Okay, a segment of a circle is a region bound by an arc and its chord. The shaded region in the figure is the segment. So they're referring to this piece right here. How to find the area of a segment of a circle. So to find the area of a segment of a circle would be equal to the area of the sector minus the area of the triangle that you can create inside. All right, so to find the area of the segment to the nearest tenth. So you got to do 2 steps. Step 1, we need to find the area of the sector. So we got to find the area as if this entire piece is what we're looking for. Then we have to subtract the triangle section out of it. So step 1 will be to find the area of that entire sector. So we're going to use our formula. A equals m over 360 times pi r squared. Our m is 90. So remember, this will be 90 degrees. And that is 90 degrees. Times pi, our radius is 3. So we're going to get 9 pi times 90 over 360. And so if we go ahead and reduce this fraction by 90, we're going to get 1/4 times 9 pi. So we're going to have 9 pi over 4 when we times them together. going to go ahead and get the decimal of that. So 9 times pi divided by 4. Now I'm using the pi function on the calculator, not 3.14 for these numbers. I don't really care which one you use, as long as you understand what you're doing. So 0, 7 when we look at the rounded number. Now we need to go ahead and find the area of that circle. So one thing we need to realize is that we have a 90-degree angle here, which makes this a right triangle. And this right here is the radius. This here is a radius, so it's the same. Therefore, we now know the height of the triangle and the base of the triangle. So we're going to find the area of the triangle of 1/2 base times height. So we have 1/2 3 times 3. Once again, this is your height, this is your base, or vice versa, doesn't matter. 3 times 3 is 9 times 1/2, so 4.5. And so now we go ahead and we're going to find the area of that segment. So area of a segment will equal the area of the entire sector minus the triangle area. So 7.07 minus 4.5 gives us 2.57 for the area of that segment. All right, so problem 5 is asking us to do the same thing, but this one is a bit tougher because we do not have ourselves a right triangle. We're still going to follow the same approach. We're going to find the area of that sector, we're going to find the area of the triangle, and then we're going to go ahead and subtract them. So we're going to have area equals m over 360 times pi r squared. So our m is 60 over 360 times pi 20r, so 20 squared is 400 pi. I'm going to go ahead and reduce the 60 over 360. It's going to give us 1/6 when we go ahead and reduce by 60. So we're going to have 400 pi over 6. I'm going to go ahead and type that into a calculator. Divided by 6, we're going to get 209.44 when rounded. Now we gotta go ahead and find the area of this triangle. But this time we know the base, which would be 20, but we don't exactly know the height. So I'm going to go ahead, I'm going to draw that triangle off for a second so we can see it a little better. But we do know that this angle right here is 60 degrees. And if I make an altitude, which is this green dashed line, making a 90-degree angle, this right here would be 30 degrees. If I know this entire length is 20, and altitude cuts it right in half, making this 10. Well, if we remember our 30, 60, 90 special right triangles, this is x square root 3, and this is 2x. Well, what we care about is this right here. We want to know the height. So if x is 10, then this is 10 square root 3. So now we know the height. So if we go ahead and find the area of a triangle, 1/2 base times height, our base is 20, our height is 10 square root 3. Just times it all together, so 1/2 of 20 is 10. 10 times 10 square root 3, that's going to give us 10 times 10 is 100 square root 3. Go to a calculator, 100 square root of 3 is 173.21 when rounded. Find the area of the segment. Is going to be 209.44 0.44 minus 173.21. We will get 36.23 meters square for our area of the segment. All right, a new topic, arc length. Arc length is the distance along the arc measured in linear units. So previously we talked about minor arcs and major arcs and their measurement. The measurement we were using was angle measures, so degrees. We cared about the angle degree that represented this arc. Now we're talking about the physical distance. Like, is this 2 inches long, this arc length? Is this 4 inches long, 5 inches, 10 inches? That physical length of traveling on that arc. Below, you'll notice in the box, there's a formula that goes over how to find it. Very similar to the one we just had for area of the section, where we were using the m over 360 times the area of a circle, but since we care about the arc, we really care about more like circumference. So you'll notice the circumference formula is part of this. So find the arc length of AB to the nearest tenth. So I care about this arc length. So I'm going to use the formula S equals m over 360 times the circumference of the circle, 2 pi r. The angle measure we have is 90 for that particular arc. So 90 over 360 times 2 pi, our r is 20, our radius. So 2 times 20 is 40, so we have 40 pi times 90 over 360. We can reduce 90 over 360 down to 1/4 by dividing the top and bottom by 90. We can do 1 times 40 pi over 4. We can reduce that down to 10 pi. And if we round to the nearest tenth, 10 times pi, using pi, not 3.14 on the calculator, I'm going to get 3.14 as the length of the arc. So the distance that we have here is 31.4 meters, the physical length. If you were walking on this circle, that's the distance you would have to travel.